Okay everyone, I'm going to be going over the chapter 5 closure worksheet that you guys had for classwork. So the first one is going to be problem 128. For these problems right here, we want to switch them to exponential form. So this one would be switched to 8 to the x equals 64. Now if you want, you can remember the ancient puzzle. So for example, log base 5 of 25 equals 2 because 5 to the second power equals 25. Now there's different ones that we saw at in the ancient puzzle, but if you want to remember one and then just remember the statement, such as this, it can help you, move between a logarithm and an exponential form, and exponential form to logarithm form. So these two equations are the same. It's just that one is in logarithmic form and the other one's in exponential form. So going back to problem A, it can help us to look at this statement and switch it. Now that we have it in exponential form, we can easily see that x has to be 2 in order for 8 squared to be 64. So in this case, x equals 2. For letter B, we can rewrite it the same way. So 9 to the 1/2 equals x. And remember that when you have an exponent of 1/2, it's the same thing as a square root. So this could be rewritten as the square root of 9, and that's equal to x. So x equals the square root of 9, but the square root of 9 is 3, so we can just simplify this a little bit more, and we see that x equals 3. Okay? So 9 to the 1/2 power is equal to 3. So for this one right here, we can rewrite it as 3 to the x equals 3 to the 4th. So right here we see that x has to be 4 in order for these to be equal. So x equals 4. For letter D, this one we have to treat it as a separate problem. So right here we see that the exponent right here is log base 10 of 100. So if we think of this one as a little side problem, maybe write it down here, we can see that log base 10 of 100 has to equal 2 because 10 to the second power equals 100. So if you think of it as, this has to equal some number, then we can say, well, 10 to the second power equals 100, so that means that this logarithm equals 2. So then this we can rewrite it as 10 to the second power equals x, and x equals 100 because 10 squared is 100. Alright, so that's it for this one. So this one you just had to kind of take care of that logarithm first. For letter E, when you're not given a base, such as this one, notice that it's blank. That means that the base is automatically 10. So you'll see that sometimes in books or in math, if they don't write anything, that means that they're saying the base is 10. So for this one, you can set this one equal to x, or even if you don't, then you can rewrite it as 10 to the x equals 100. So we have the same situation as over here. So this would be 2. So x has to be 2 in order for this to be true. Maybe something you're wondering is, why did they show the base 10 over here? Well, that's just because we wanted you to see the relationship between this base 10 and log base 10 and what happens. So maybe you saw it, maybe you didn't, but if you noticed, the base 10 and the log base 10 pretty much canceled each other out, and that's why we ended up with 100. But that'll be something that as time goes by, you'll probably be able to see that relationship. So sometimes you'll usually see it like this, where they don't write the base. In this one, they wrote the base of 10 just so we can kind of notice what happens. Alright, moving on to 129. Problem 129, we're looking at the original graph, which is over here on the right. And for this graph, the domain, we talked about it. It's going to be all x values that are greater than or equal to -4, but less than or equal to 3. Oops, not equal to, because we have this open point. So notice there's an open point right here. So this means that it's going to just be less than 3. For the range, our graph, the y values go as low as -5 and as high as 5. So our range is going to go from -5 to 5. So x is greater than or equal to -5, but less than or equal to 5. And just so you guys know, you're welcome to, fast forward to this video, because I know some of you guys already worked this out. So just know that you can do that. This one is a function because of the vertical line test. So if I draw a vertical line anywhere through this graph, you can see that it's only going to cross once, and that's the vertical line test. If it only crosses once at any point on the graph, then that means that yes, it's a function. So that is a function. For the inverse, you can just look at each coordinate point and switch the values. So if we switch the -4 and the 2, the point for our inverse is going to be 2, -4. So this one would be a 2, -4. If we look at our next one, the new one's going to be 5, -3. So 1, 2, 3, 4, 5, -3. If we look at the next one, it's going to be -5, 0. 1, 2, 3, 4, 5, 0. And if we look at the last one, it's going to switch to -1, 3. So our new one's going to be -1, 3, which is up here. And now we need to connect them in the same order that this one was connected. So from this one to this one, then to this one, and then to this one. So this is the first one, then it goes to this one, then it connects to this one, and then finally it connects to this one. And there's our inverse graph. So the first question is it an inverse function? We can see that it's not, so no, because it doesn't pass the vertical line test. So if I draw a vertical line here, you can see that it's going to cross twice. And if I draw one here, really there are several places where I can draw a vertical line and it'll cross it twice. So it doesn't pass the vertical line test. So this one doesn't pass vertical line test. Now for the domain and range, we're going to look at our inverse function. Notice that it goes from -5 all the way to 5. So all the x values that we see here where this graph has outputs is our domain. So the domain is going to be from -5 to 5. Our range is going to be all the y values that represent outputs on this graph. So if we see there's outputs all the way from -4 to +3. So our range is going to be all y values that are greater than -4 but less than 3. If you notice, the domain for the original function and the range for the inverse function are pretty much the same. We just switch the variables, and our domain now becomes our range for the new one. So that's something that's always going to happen. So the original function is going to have a domain that will switch to the range of the inverse function. So notice that for the domain, same thing. The range and the domain switched. Okay. So that's a relationship that you will always see with domain and range of original and inverse functions. All right, let's move on to 130. So for problem 130, a gallon of milk costs $3.89 and inflation has steadily increased at 4% per year. Whenever you see that we're increasing or decreasing by a percentage, then that's gonna represent an exponential function. Every time that you're talking about increasing or decreasing by a percentage over the years or over days. So for this one, we should already be thinking of the equation y equals a times b to the x. And we can start kind of plugging in our values into this equation. So the first thing is our initial value is 389. And our multiplier, Most of you would think that it's 1.04, but that's if we are going forward in time. But for part A, notice that we're talking about 10 years ago. So if we're going back in time, then instead of adding 4% to 100%, we need to subtract 4% from 100% because that'll cause a decrease. So 100% minus 4%, that's 96%, which as a decimal, 96% is equal to 0.96. So our multiplier in this case is 0.96, and this multiplier will cause for our amount to decrease by 4% each year as we go back 10 years. So we're going to plug in 10, and as we saw in most cases in class, this gave us $2.59. So the price of the gallon of milk 10 years ago was $2.59. For this one, letter B, it's asking us how much longer will it be until it costs $10. So for this one, now we know that $10 is what our answer is going to be. Our initial is still 389, and our multiplier this time will be 1.04 because now we are asking about 10 years from now, so it is moving forward in time. So the number of years it will take, that we don't know, so we're going to call that X. But here, if we use guess and check, just plug in 3.89 times 1.04 to, and then just guess a number for the exponent and see what, you see what you get. So for this one, we should have gotten that X is about 24 years. So in 24 years, the gallon of milk will be $9.97, but if we round up to $10, that's about how many years it'll be. So that's the answer for the letter B, 24 years. All right, for 131, let's start with A. For letter A, to add these fractions, we want to add these fractions. Notice that it says perform the indicated operation on each of the following rational expressions. Be sure to state and excluded values. So it's telling us to add these fractions. So in order to add them, we need to have a common denominator. But in order to see what the common denominator is going to be, we need to factor, or maybe you can see it already. I know some of you might see that it's x minus 3. But if we factor this, we can see it more clearly. So this one, 5x over x plus 3 plus x plus 3. Notice that I switched this, so 3 plus x is the same thing as x plus 3. So you can switch it if you want. And x squared minus 9 is a difference of squares. So anytime you have a difference of squares, it'll factor out to x plus 3, x minus 3. Or similarly, notice that the x can be obtained by squaring the x, and the 9 can be obtained by squaring the 3's. So you'll always have those two plus, and then the same two but minused. So that'll be your case every time. Now we can see that x minus 3 is what we need to make these common denominators. So in order to do that, we multiply by x minus 3 over x minus 3. And that way we can get 5x times x minus 3 over x minus 3 times x plus 3. Over here we'll get x plus 3, x plus 3, and x minus 3. It doesn't matter if they're switched, so notice that right here we have x minus 3 times x plus 3, and over here where they're switched, that's okay, still the same denominator. So now we can combine these fractions into one, so that'll become 5x times x minus 3 plus x plus 3. So this will become x minus 3 times x plus 3. And if we look here, most of us thought that we can cancel out or build a big 1 with the x minus 3 and the x plus 3, but we can't do that because we're adding. If we were multiplying everything, then we can cancel those out, but since we're adding, then we can't do that. If we distribute the 5x, then we'd get 5x squared.